Okay, so we are going to start specimen paper for 2023. Let's start with question number 1. Now, here in this question, choose from the list of oxides to answer the questions. Okay. Each oxide can be used once, more than once, or not at all. So, identify which oxide has a giant covalent structure.
The silicon oxide.
So it's
Silicon oxide.
oxide. Then the next one reacts with acids and with alkalis. It's zinc oxide because zinc oxide is amphoteric. Then is used in flue gas desulfurization. Yes. Flue gas desulfurization. Yes.
Sir, calcium oxide.
Very good. Class के पास बात करते हैं. Okay, so here we have a calcium oxide. Then they are asking about the one oxide contains a cation with a charge of +1. So group 1 elements have a charge of +1. So
sodium
here it's a sodium. So it's sodium oxide. Who left the classes, sir? Now, question number 2. Atoms and ions contain protons, neutrons, and electrons. Complete table 2.1. Okay. So, if you recall, they have mentioned the charge of proton, that is the relative charge, it's +1. And if you recall the relative mass of proton, it is also 1. When we talk about the charge of neutron, the relative charge of neutron, because it's a neutral, the relative charge of electron is -1, and the relative mass of electron is 1/1840. Write it 0 as well. Okay.
इससे मार्क नहीं कटता.
No.
सर, अगर हम लोग इलेक्ट्रॉन का मास 1/1840 लिखें तो काउंट होगा?
Yes, you can write 1/1840 as well. Both are considered as correct.
Okay,
That's
sir.
fine.
Okay.
Okay. Now, next, table 2.2 shows some information about 6 particles. Okay. Now here,
57 minus 48, 11.
Reduce the neutron number of particle A.
85.
So, call neutron number, yeah, it's a sum of protons and neutrons, and the protons are 37 and the neutrons are 48. Yeah, when you add them, it gets you 85. Right? Then explain why particle B is a negative ion. So let's have a
Sir,
look
it
at
is one
particle
more
B.
electron than
It have
the
a
number of
50
protons.
protons and 54 electrons. So there is 54 negative charges and 53 positive charges. So we just left with a one negative charge that makes it negative. So we write that B has, or we have one more electron. Is this clear?
Yes, sir.
No. Just mention that it has a one more electron, and I suggest further you mention that as it have 53 protons and 54 electrons. Now, next part, identify the part 3 from question number 1. B3. Identify two atoms
Sir, it's C and E.
that
Same
are
number of protons.
isotopes of same element. So C and E have an equal number of protons but different number of neutrons. So here I have write C and E. Then we have a explanation that yes, both
Have same proton number.
have same number of protons but
Different number of neutrons.
different number of neutrons. Okay. Yeah, that is also fine. Question number 3. Salt can be prepared by a reaction of acid with bases or alkalis and also by precipitation reaction. These are the 3 ways by which we can prepare a salt, and we discussed all 3. State the ionic equation for the reaction between an acid and an alkali. So remember, whenever you have to write the equation between the acid and an ionic and alkali, and that equation you have to write as ionic one, so you have to just use hydrogen ion and hydroxide ion, and they turn into water. That is the ionic equation for any acid or and with any alkali.
Sir,
Yes.
sir.
Yes.
जो आयनिक चार्ट लिखना होता है ये मार्क तो नहीं कट होंगे अगर आपने लेफ्ट या राइट पर ऊपर लिख दिए सिंपल के या नंबर और सिंपल अलग जगहों पर लिख दिए लाइक अगर 2 नेगेटिव से पहले है या 2 नेगेटिव के बाद है
No,
चार्ट
it doesn't. There is no issue in writing +1 or a 1 plus or -2 or a 2 minus. Both are considered as correct. Okay. You are talking about like this, right? If I am writing sulfate with a 2 negative charge, or I will write sulfate with a with a -2 charge, right? That's what you are asking.
Yeah. Yes.
So both are considered as correct. Okay. Now, B part of question 3. Sodium sulfate is a soluble salt prepared by titration method using an acid and an alkali. Identify the acid and alkali prepared to use to prepare sodium sulfate. So sulfate
So
comes
sulfuric
from,
acid and
it's a sulfate which comes from sulfuric acid, and it's a sodium. So sodium must come from
and sodium hydroxide.
sodium hydroxide. So
सर यहाँ पे सोडियम ऑक्साइड भी करेक्ट होगा ना, क्योंकि सोडियम ऑक्साइड भी सॉल्युबल होता है.
yeah, but we are doing the titration, right?
Yes,
And in
sir.
titration we use aqueous solutions. And in aqueous solution there is no oxide, there is always a hydroxide in the aqueous solution.
Okay, sir.
Yeah, here they have used the term identifier, so you can write the formula or the name. But when the examiner say write the name, so if you do it, then that would be wrong. If the examiner says name, then you have to write the name. If the examiner says formula, you have to write the formula. For example, here examiner saying identify the acid, so you can either write the name or the formula. Now, C part. Aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. Okay, because barium sulfate is an insoluble salt. See over here, they have mentioned that when the aqueous ions are joining, a solid is forming, which indicates that it's an insoluble salt. In an experiment, 20 centimeter cube of 0.005 mole per dm cube of barium nitrate. So this is the concentration of barium nitrate, and this is the volume of barium nitrate. Is added to an excess of sodium sulfate. State the color of the precipitate formed in the reaction. Yes, barium sulfate. Which color they show?
White, sir. White.
White. Very good, because it's a group 2 compound. So if it's a group 2 compound, then it will show you, white precipitate, because group 2 compounds doesn't have any color. Classroom. White solid or white precipitates. Okay. Now, calculate the maximum mass of barium sulfate that could be made. Okay. So they have told you that we have used this volume, that 20 centimeter cube volume of barium nitrate of a concentration of 0.550 mole per dm cube, and they have asked you to find the maximum mass. Okay, so if you look over here, that let me write the formula of barium nitrate. Barium nitrate is BaNO3 taken twice, so it have a 1 barium ion in it and 2 nitrate ions. So the ratio of the moles of barium ions and barium nitrate would be the same.
Sir, barium sulfate.
No. First, we are provided with the concentration and volume of barium nitrate. So first we have to find the moles, find the moles of barium nitrate or the barium ions. Then we would go for barium sulfate. Okay. The barium sulfate, we have to find its mass. So they have provided us the volume of barium sulfate, barium nitrate, and they have provided us the concentration of barium nitrate. So from this ratio, I can conclude that whatever the moles of barium nitrate I could obtain, whatever the moles of barium nitrate I would obtain is actually the moles of barium only, because the mole ratio between the barium nitrate and the barium are same, right? So to find the mole, what I have to do, I have to multiply the concentration of the barium nitrate solution by volume, and as volume is in centimeter cube, so I have to convert this volume into decimeter cube, and for that I will divide it by 1000. Yes. So what will be the moles of barium over here? 0.011 moles of barium ions that I have found. Now, if you look at the above equation which is provided in the question is suggesting that 1 mole of barium is going to produce 1 mole of barium sulfate, right? So, if 1 mole of barium is produced, is there, then 1 mole of barium sulfate would form. So, the moles of barium that I have found is actually the moles of barium sulfate as well. So the moles of barium that I have, barium sulfate would be 0.011. And if I have to find the mass of barium sulfate, then I have to multiply these moles of barium sulfate with its MR to turn into mass. So here the MR is provided, that is 233. So multiply by 233 would give you the mass. Yes. 2.563 grams.
2.563.
2.563. Yes. If you are getting the same answer, then it's correct. Yeah. It doesn't depend upon the method. If you are getting the correct answer, then it is always correct. Okay.
सर अगर हम लोग वाला क्वेश्चन जल्दी से इक्वेशन बना वो पूरा इक्वेशन लिख के फिर उसके बाद मोल रेशियो के थ्रू कर लें तो कोई इशू तो नहीं होगा ना?
No issue in either way.
और सर एक और, ये जो आपने अभी प्रेसिपिटेट कलर निकाला था बेरियम सल्फेट का, तो उसके अंदर जो पीछे हमें टेबल पढ़ाया गया था उसके अंदर है कि सल्फेट्स के प्रेसिपिटेट्स हमेशा वाइट बनते हैं, तो सर
Yes,
अगर उस
no. It depends upon the whole compound, because when we talk about copper sulfate, the copper sulfate solid is blue, right?
Yes, sir.
So here it is basically, it's not a transition element. So if the compound is of a non-transition element, then it is always white.
Okay, sir.
Non-metals के colors?
Sorry?
Non-metals के colors?
Yes, transition metals compounds are colored. If the transition metals are not there in the compound, then the compounds are white. Okay?
सर क्या क्लोरीन के compounds क्या yellowish होंगे?
No, chlorine is not a transition element, right? Yes. Yes, is Hassan is chlorine is a transition?
No.
So chlorine itself is a pale yellow or pale green gas, but when the compound of a chlorine is formed, that is usually white unless if that compound contains a transition element in it. Okay?
Okay, sir.
Hassan, is it clear to you as well?
Yes, sir.
So if that compound contains a transition element in it, then it will show you a colored compound. Otherwise, if the transition element is not there, then the compounds are not colored. So sometimes the students argue that the halogens are colored and they are not transition. So yes, the halogens are colored, but the halogens are colored when they are elements, not compounds. I'm talking about Cl2. So Cl2 is pale green, but Cl2 is Cl2 a compound. Bromine, Br2 is a zinc is not a transition element. So bromine is a red brown or brown. and it's not, it's an element. When you look for the compound of the bromine, that are sodium bromide or lithium bromide or calcium bromide, so they all are white. In the same way, sodium chloride, potassium chloride, lithium chloride, magnesium chloride, strontium chloride, all are white unless they are bonded with a transition element. Okay, if there is a copper chloride, because copper is a transition element, so that it must be colored. Is this clear?
Yes sir. सर ट्रांजिशन एलिमेंट्स के कलर्स, तो ट्रांजिशन एलिमेंट्स के जो कंपाउंड्स होते हैं उनके कलर्स पूछे जा सकते हैं?
Yes, normally they ask me for the copper sulfate. We remember that it's blue in color. Okay.
कॉपर सल्फेट का पूछा जा सकता है?
Yes.
कोबाल्ट
And
क्लोराइड
sometimes
का
they
पूछा जा
ask me
सकता
the
है?
copper. Yes, cobalt chloride pink.
पिंक होता है सर एनहाइड्रस, और हाइड्रस में वो ब्लू हो जाता है.
Blue हो जाता है. Yes.
एनहाइड्रस ब्लू
Normally
होता
they
है
ask. Yes, and
और
the
हाइड्रस
color of the potassium magnate. KMnO4, which is
पोटेशियम
purple.
मैग्नेट इज पर्पल.
Yeah. So that's what examiner can ask. Otherwise, if they have given you some other, transition element compound, then they have mentioned the color as well. Okay.
ओके सर.
A mass of 1.92 gram of barium sulfate is obtained. Calculate the percentage yield. Okay. So what they are telling us that from after the experiment, after the practical, the mass obtained for barium sulfate is 1.92 grams, and from the calculation we got the mass is 2.563, and they are asking you to find the percentage yield. So percentage yield is always equals to practical value or practical yield divided by theoretical yield or theoretical value multiply by 100. So can anybody tell me the answer? 74.9%.
Yes, sir.
No, if the unit is mentioned over here, then there is no need. But if the unit is not mentioned in the space, then you have to write the unit.
ओके
No, I
सर.
don't. Okay. Now question number 4. Calcium chloride is an ionic compound. Reduce the electronic configuration of each of the ion in calcium chloride. So if you will find in the periodic table that calcium is from group 2 and chlorine is from group 7. So if calcium is in group 2, then calcium must have a 2 positive charge and its atomic number is 20. So it means there are 18 electrons because 2 positive charge shows that it have a 2 electrons less. Chlorine, its atomic number is 35 and it have a -1 charge. So
Sir, it will be 288 for both of them.
sorry, yeah, so its atomic number is 17. So -1 charge makes it 18, so 18 electrons over here as well. So both have a same number of electrons, which is 18. So I will write the electronic configuration. It will be
288.
8. In the same way, it's for chlorine 288. Okay. Now, part B. Question number 4, part B. When calcium chloride is electrolyzed, molten calcium chloride is electrolyzed with inert electrodes, calcium and chlorine are formed. Construct ionic half equation for the 2 electrode reaction. They have actually told you that what are forming at the electrodes. So at negative electrode, obviously the positive ion must be attracted, and the positive ion is a calcium 2 positive ion. So what it would do when it reaches to the negatively charged electron, it goes and gain the electron and becomes a calcium metal. In the same way, at positive electrode, the chloride ion must be attracted where it uses its electron to form a chlorine. And if you recall, chlorine is a diatomic, so I will put 2 over here. And then if I'm putting the 2 over here, so there must be a 2 chloride ion. So I will put 2 before the chloride ion, and then 2 electrons must be lost because each chlorine atom have a 1 extra electron. Is this clear? Now, C part, the electrolysis of concentrated aqueous calcium chloride. Now, see, it's aqueous concentrated calcium chloride, which means now it have a calcium ion, chloride ion, and the ions from the water that are hydrogen ion and the hydroxide ion with inert electrodes as similar to that of concentrated aqueous sodium chloride. Okay, predict the products of the electrolysis of concentrated aqueous sodium chloride. So, as it is concentrated, so the chloride ion will oxidize at positive electrode, forming chlorine gas, and as it's aqueous and hydrogen is below in the reactivity series, so instead calcium, hydrogen would go and form hydrogen gas at cathode. So here they have asked you for the products. So the products are over here. Hydrogen and chlorine. Okay. It's a negative ion, and for negative ion, we always decided with the amount. It's a concentrated one. So in concentrated, instead of hydroxide ion, if there is a halide ion, it goes. And if instead it's a diluted one, then instead of chloride ion, hydroxide ion would be reacted at the anode forming oxygen gas. So it is decided the negative ion, which negative ion is going to react at anode is actually decided by the amount, the one which is in the greater amount. But remember, when there is a sulfate and nitrate, they do not oxidize at anode, whether are concentrated or diluted. In that case, only hydroxide forms oxygen for the sulfate and nitrates. Now, D part, calcium chloride has a high melting point. Explain why calcium chloride has a high melting point. Use idea about structure and bonding. Okay, so we know that there are ions, which makes it that we can write that calcium chloride is giant ionic lattice. So that's what I have commented about its structure. Now, for bonding, I would write that there are strong ionic bonds between calcium ions and chloride ions throughout the structure. Or throughout the lattice. Is this clear?
Yes, sir.
Yes, sir.
Now, question number 5. Yes. No, how is between the bonds? Which particles? So you must write there are strong electrostatic forces of attraction between the positively charged ions throughout the structure. You have to write throughout the structure because in the ionic lattice there is only one kind of attraction, which is actually throughout the structure. Figure 5.1 shows alcohol, ethanol, and butanol. Describe the manufacture of ethanol from ethene. Yes. To form ethanol, no. Fermentation is due when we do the fermentation is when we do when we reacted with the glucose and yeast, when we mix the yeast with the glucose. So ethene, if you recall, ethene is a 2-carbon containing compound having a double bond and the hydrogens. Then when we put a, it reacts with the steam because high temperature was there. Steam is broken down into hydrogen and the hydroxide. So one carbon takes the hydroxide, the other carbon takes the hydrogen, and the double bond it turns into a single bond, and see, ethanol is formed. So we have to describe it. So we can say that ethene reacts with steam in the presence of acid catalyst. And further, if you want to mention, you can mention the temperature that we use normally is around 300 or 350 degrees Celsius.
सिर्फ टेम्परेचर 300 डिग्री सेल्सियस होता है और 60 atm का प्रेशर भी होता है ना?
Yes, but it's for 2 marks, so I have written the 3 conditions.
Okay, sir.
Ethanol is used as a fuel. State one other use of ethanol.
Sir, beverage and solvent.
Yeah, it is used as a solvent. It is used in beverages. It is used for making vinegar as well because it is oxidized to ethanoic acid and vinegar. So used as solvent. Now, construct a symbolic equation to show incomplete combustion of ethanol. Whenever there is an incomplete combustion, what are the products? Carbon monoxide and water are the products. So ethanol is C2H5OH reacting with oxygen, forming carbon monoxide and water. So if I will balance the equation, there are 2 carbons on the left, so I will put 2 before CO. There are 6 hydrogens on the left, so I will put 3 before hydrogen. Now the oxygen on the right side are 5 and the oxygen on the left side are only 3, right? So if I will put 2 over here, that makes 4 oxygen over here and 1 oxygen present in the ethanol makes the 5 oxygen on both the sides. The equation is balanced. Is this clear?
Yes, sir.
Yes, sir.
Ethanol is oxidized to form ethanoic acid. Suggest the name of the reagent that is used for the oxidation.
Sir, oxygen or KMNO4. Acidified potassium, aqueous
Acidified potassium magnate. And instead we can just write oxygen as well, but the appropriate answer would be acidified potassium magnate 7, which is KMNO4. Okay. Draw the displayed formula of a different alcohol that is isomer of butane 1.
सर डाइक्रोमेट नहीं यूज कर सकते,
Sorry.
डाइक्रोमेट नहीं देख सकते.
Yes, you can write the dichromate, but I think that now the dichromate is not the part of the syllabus. Potassium dichromate.
नहीं,
Marks
मिलेंगे क्या नहीं?
No, you can be awarded a mark for that as well. But we have to keep in the boundaries that are provided from the Cambridge. Okay, so we have to draw the isomer of a butanol. So if you recall, what is isomer? Having a different structure, the compound which having a different structure. Okay, so what does the name butane 1 is telling me? It is telling me that the first carbon have a OH out of the 4 carbon. So, and what is the displayed formula means? The formula which have all the bonds shown. So what I will do, it's a butanol which means 4 carbon atoms. So I will draw 4 carbon atoms in a row like this. Then I can put a OH bond on the second carbon. So it's now this would become a butane 2-ol, which would be the isomer. So on the first carbon there are 3 bonds are left to me. So I will place 3 hydrogen over here. Then I will place a 1 hydrogen over here, 2 hydrogens on this carbon, and the 3 hydrogens on the carbon on the left. So this is the displayed formula of butene phenol. Is it clear?
Yes, sir.
Yes.
Okay. Now, key part. Butene phenol heated with concentrated sulfuric acid, which act as a catalyst. But1ene and the other compound are formed. So see, they have provided you the information over here. This reaction is not the part of the syllabus. That's why they have provided you which one is the reactant and what product they are forming. See, if this reaction is the part of your syllabus, then it could be asked in the same manner. For example, they have asked you the preparation of the, steam of ethanol from ethene. They have didn't tell you anything. They just told you how you will make this. But here they will given you the reactant. They have given you the product, and they have given you the condition as well. That what you are doing, you are using the sulfuric acid as a catalyst, and you are heating as well. So these two are the conditions. Now, what they are asking, draw the structural formula of butene. So butene means the one compound having the 4 carbons and a double bond on the first one. So first carbon, if have a double bond, then it must have a 2 hydrogens bonded to it. And the second carbon, which have a double bond, as it's a part of the chain, so it have a 1 hydrogen with it, then it bonded to a next carbon with a CH2, and then the last one with a CH3. So this will be the structural formula of butene. Is this clear?
Yes, sir.
In this way, whenever they ask you to write the structural formula, you have to write the structural formula. If you make the displayed formula over here, or if you have shown any bond here instead of a carbon double bond, then you will be marked wrong. Which one? It's a displayed formula. You will not get the mark because you miss the conditions. So, but they have mentioned right now the structural formula, right? They have mentioned you the condition. Now, what they are asking, reduce the other compound formed in this reaction. Who can tell me the other compound is similar?
Water.
H2SO4 is a catalyst. So how could it form? You are getting this from which molecule? You are getting butene from which molecule? Why? What you are thinking? Look over here. Butanol. Butanol is turning into butene. So if you draw butanol, you would see CH3, CH2, CH2, CH2OH. So if you compare these two, what you would find, a OH group and the H is missing. So OH and the H that is removed from butanol would turn into water. So the other product is water. Is this clear? Yes, is it clear to everyone?
Yes, sir.
Yes, sir.
Okay. Now, butene is polymerized to give a polybutene. State the type of polymerization that occur. Yes, very good. Because the compounds containing a double bond undergo only addition polymerization. Okay. The compound, any compound containing a carbon-carbon double bond undergo addition polymerization. Now, Draw the structure of polybutene showing at least one repeat unit. Arish, you have a problem with that? Now understand.
Yes, sir.
Okay. So what I will suggest, whenever you have to make the repeat unit of an addition from the addition polymer, from the monomer which have a carbon-carbon double bond, first do the rough work. You all do with a pencil. Write a carbon, then put a double bond, then write the other carbon. Okay, just do this. Now, if you see that on the left side of the double bond mentioned in the question, what groups are there? I have put this carbon over here. Now, what is left behind? On the left of the double bond? Here, this H and on the left of the double bond, we are left with H and CH3, right? So you can put two bonds, one above and one below, and it's up to you whether you will put H or whether you will put CH3. It doesn't matter. Okay. Then do the same thing on the right side as well. That place a CH3 on one side and the H on other side. It doesn't matter where you are putting it. Okay. After doing this, what you would do, you would remove the double bond, make it a single bond, and then place empty bonds on left and right. Okay.
Yes, sir.
Yeah. So this is one repeat unit. So for example, if the examiner asks you to draw the two repeat units, so what you would do? You would repeat the whole unit like this in its neighbor. And if the examiner asks you to write the three repeat units, then you repeat it once again in the neighbor. Now there are three repeat units. So in that way, you can make three repeat units or two repeat units. Yes, so I am just keeping it at one, but if someone said make two repeat units or three repeat units, in this case, that is correct. Because that is the minimum condition that you have to draw one, but you can draw two or more as well. Okay. Is this clear?
Yes, sir.
Yes.
Now, question number 6. A mixture of ethanoic acid, ethene, and oxygen is passed over a catalyst at 200 degrees Celsius to manufacture ethynyl ethanoate. Okay. And here they have given you the equation as well. That you have a ethanoic acid in it, you have a ethene in it, and oxygen. And as a result, we are getting these, this compound and water. So if you look at closely to this compound, what functional groups are there? Yes.
Sir, carboxylic acid.
Carboxylic acid, no, wrong, completely wrong answer. COOH is a carboxylic acid. There is a C double bond O is not a carboxylic acid. If C double bond O is bonded to H, it is a
ester.
carboxylic acid. Yes, very good. This group indicates that there is an ester over here, and here carbon-carbon double bond means there is a C double bond C or alkene. Okay, so there are two different functional groups present in the product, in the one molecule, right? Is this clear to everyone? Now,
Yes, sir.
what they have told us about the reaction, that the reaction is exothermic. Draw a reaction pathway diagram for this reaction on figure 6.1. So it's exothermic, which clearly means that the delta H is a negative value, right? And if the delta H is a negative, which means that the energy of the enthalpy of the product must be lower than the enthalpy of the reactants. The reactants are at a higher energy and the products must be at the lower energy. On your diagram, you have to label excesses. Okay, so do it on y-axis. We either label it with the enthalpy and enthalpy is also called energy. So either you can write enthalpy or you can write energy. Both are considered as correct. Okay. And on x-axis over here, you can write. You can label it with a reaction progress. Okay. Or instead of writing reaction progress, you can write it extent of reaction as well. Okay, now we are done with the first part, the reactants and the products. Okay, so as we have decided that the enthalpy change is a negative, which means reactants must be at a higher energy and the products must be at a lower energy. So here I have a reactants and here I have a products. Is this clear? Now the enthalpy change of the reaction. So enthalpy change is the distance between the reactants and the products only. So if I have to label the enthalpy change, I can start from the reactants till the level of the product, and by putting the arrow downward because the energy is released, I would label it as a delta H. Now I am done with the third part as well. Now the fourth part is the activation energy, and for activation energy I have to draw this arc like shape over here. Okay, I have to draw this arc like shape over here, and here the activation energy starts from the level of the reactants to the highest point of the curve, that is activation energy. Okay. So here you go. Okay. Now, explain why the enthalpy change of the reaction is exothermic. Using idea about bond breaking and bond making, we have discussed these in the previous papers as well. Yes. What we would do, we would state that bond breaking is endothermic and bond making or forming is exothermic. This reaction is exothermic because the energy released is more or is greater than the energy absorbed. Is this clear to everyone?
Yes, sir.
Now, question number 7. Peroxodisulfate ions having the formula of S2O8 negative reacts with iodide ions in aqueous solution. Iodide ions are oxidized in this reaction. State how the equation shows this. So So if you look at over here, the iodide ion have a -1 charge, and over
Loses
here
loses
it
electrons.
becomes iodine, yeah, which is 0. So the oxidation number of iodide is changing, of iodine is changing from -1 to 0, which indicating that iodide ion loses electron. Iodide ion loses electrons. Okay, now table 7.1 shows how the relative rate of this reaction changes when the different concentrations of peroxide disulfate ions and iodide ions are used. Okay. Using the information in table 7.1, describe how increasing the concentration of each of these ions affect the relative rate. Okay. So if you compare reaction 1 and reaction 2, okay, what I am going to do, I am going to compare experiment 1 and experiment 2. If we observe experiment 1 and experiment 2, the concentration of iodide ion is constant. Yeah, it doesn't changes. But if you see, the rate of reaction is actually increased by some factor or some integer. In the same way, the concentration of S2O8, that is peroxide disulfate ion, is also increased by some factor. So from experiment 1 and 2, I am going to clearly observe the effect of the concentration change of peroxide disulfate on the rate. So because why? Because the concentration of iodide is not changing. So whatever the change in the rate is taking place is actually due to the change of the concentration in peroxide disulfate. So you will clearly see that in the first experiment the concentration is 0.008 for peroxide disulfate, and the concentration of peroxide disulfate in experiment 2 is 0.016. So it means that the concentration is getting doubled, right? So if you see, the rate is also getting doubled, not exactly double, because if I times 2, it becomes 3.4. So it is around 1.99, right? So the concentration of the peroxide disulfate ion is getting doubled, and the rate of reaction is also getting doubled, right? Is this clear? So here I can write that it's of 2 marks only for both. So I can write that on doubling the concentration of peroxide disulfate ion, the rate gets doubled to. So it's a just one, it's a 1 decimal point plus. So it is almost doubled. You can just write that in the concentration, the rate will also increases. That is also fine. Okay. Now, for to observe the effect of iodide, I can compare experiment 4 and 5. Why? Because in experiment 4 and 5, the concentration of peroxide disulfate ions are constant, right? And if you see that the concentration of iodide is getting doubled, and if you see the rate is also almost getting doubled or a 0.1 value greater than double, right? So here I can write as well as the iodide or the concentration of iodide gets doubled, the rate gets doubled as well. Is this clear to everyone? If anybody have any doubt, any issue, kindly ask. Yes, is it clear?
Yes, sir.
Yes, sir.
Okay. Now, C part. Iron 3 ions catalyzes this reaction. Explain how catalyst increases the rate of reaction. And it's of 2 marks.
Increase the speed of reaction by lowering the activation energy.
So, catalyst
Increase the rate of reaction.
lowers the activation energy.
Activation energy.
Sorry. It's for 1 mark only. If there is a for 1 mark, you can just write that. But when it's for 2 marks, you have to explain. So it lowers the activation energy. That is the first thing. So when the activation energy is lowered, what would happen? Yes, it lowers the activation energy. So when the activation energy is lowered, what would happen?
So the rate of reaction increases.
But why?
The alternative path.
So what actually alternative pathway is doing? It is seen, for example, if there is a big mountain and there are 100 people on the one side of a big mountain and they have to, climb to the big mountain to go over the other side. So out of those hundreds, only I think 2, 3 or 4 are going to climb and cross the big mountain. But when instead, if you will find that there is a tunnel over here in the big mountain, so that is the alternative route. And from that tunnel, almost all of the 100 people can,
So we can write more number of successful
so
collision.
yeah, very good. So that's what the alternative route is doing. That now it is providing you that now the actually we have a more proportion of the molecules having the energy greater than the activation energy, because that tunnel, it can be, everyone can pass through it. So in the same way that the molecules which have a lower energy and which are not actually able to cross the initial activation energy to convert it to product, but when we edit the catalyst, the activation energy goes down. So those molecules can also, have a now more energy than the new activation energy. So what it would do that by adding the catalyst, the activation energy gets lower, and when the activation energy gets lowered, what would happen that more proportion of the molecules, more proportion of molecules or particles have energy greater than and equal to activation energy, right? And as a result, more successful, more frequent successful collisions occur. So it's for 2 marks. I think these 2 points are enough. Now, question number 8. Copper reacts with a concentrated nitric acid to form copper to nitrate. Okay, here we have an equation. What is meaning of a AQ? Yes, who is going to tell me?
The state symbol aqueous.
It means aqueous, which means dissolved in water. Okay. Now, an excess of copper is added to 25 centimeter cube, 1 mole per dm cube nitric acid. So it's a concentration over here and it's a volume over here. Use this information to gather the equation. Okay, here we have the equation to calculate the volume of nitrogen dioxide formed. The gas volume is measured at room temperature and pressure. Okay, so first what you need to do, you have to find the moles of nitric acid. To find the moles of nitric acid, what we will do, we will multiply the concentration of nitric acid with the volume, but the volume must be in decimeter cube, and for that we have to divide it by 1000 because the volume provided is in centimeter cube. So just multiply and tell me the answer, please. Sorry, is it 0.4 moles? Yes.
Yes, sir. 0.4 moles.
So 0.4 moles of nitric acid are there. Okay. What we have to find? We have to find the volume of nitrogen dioxide. Okay. Now, if you look in the equation, from equation, what I can conclude, I can take the ratio between the nitric acid and nitrogen dioxide. Further, I can take that ratio between the moles of nitric acid and the volume of nitrogen dioxide directly by the number of moles only. So what I am observing in the equation that there are 4 moles of nitric acid are reacting. How much nitrogen dioxide is forming? Yes.
Sir, 2.
2 moles, and when I am taking the ratio of a mole versus volume, so we know that if there are 2 moles at room temperature, then the volume must be 2 times 24, which is 48 decimeter cube. So I directly have the ratio of a moles and the volume of a gas, moles of acid with the volume of a gas. So in the question, we have used 0.4 moles, so the volume must be X, and X must be, I think, it's 4.8 dm cube.
Yes, sir.
You just cross multiply to find the X. Okay. When heated copper 2 nitrate decomposes to form copper oxide, nitrogen dioxide, and oxygen. Okay. So what they are saying that on heating copper 2 nitrate, we will get copper oxide, copper 2 oxide, nitrogen dioxide, and oxygen. Construct the simple equation for this reaction. See here, it's very easy for you. Why? Because they have provided you the formula of everything, and you have to put it in the equation and then balance it. So copper 2 nitrate, an ionic compound, so it must be solid. When I heat it, it decomposes to give you copper 2 oxide, which is a metal oxide, which is also solid, and a nitrogen dioxide, which is a gas, and oxygen, which is also a gas. Okay. Now, if you have to balance this equation, you have to balance in this manner that you have to put 2 before the NO2 and half before O2. Now your equation is balanced. Because there are 6 oxygens on the reactant side. So in copper oxide, there is a 1 oxygen. In NO2, there is a 2 oxygen. So 2 times 2 gives it 4. And 1 oxygen from metal oxide, so 5. So we need 1 more. So I have to put half before O2. And okay, can anybody tell me what will be the observation over here? Why light blue precipitate form? Precipitate never forms unless the solid is formed in the liquid. There is no liquid. The solid is turning into another solid. So how could you don't use the term precipitate until we mix the 2 liquids, and on mixing the 2 liquids, there must be a formation of a solid within the solution. Then it is considered as a precipitate. Otherwise, you can't say precipitate.
Sir, black solid.
Where solution? Where is the solution? Where is the liquid? Yes, Asad or Sakid, who is telling me the answer?
Sir, black solid.
Very good. Because copper 2 oxide is of black color. Any other observation beside this?
Sir, gas.
Okay. But how could you observe the gas? Because gas can be observed only when the gas is forming in the liquid. Then you can observe it as it forms a bubbles. But the gas is forming from the solid, or it is escaping from the solid. Then you could not observe, or you could not have to observe the gas unless that gas is colored. So, for your information, the NO2 formed over here is of a brown color gas. So you are going to observe the brown fumes releasing from the solid. So that is the another observation for this reaction. Okay.
Sir, so nitrogen dioxide is brown.
Yeah, nitrogen dioxide is brown. Actually, this equation is normally asked in AS level, and the observation is there as well. But they have asked you in the O levels. That's why they have provided you the reactant and the products, all the things, and you just need to balance the equation. In AS level, they just ask you to write. They said that write the decomposition of a equation for a copper nitrate when it is heated. That's it. So you have to remember in A levels that when we decompose a metal nitrate, we are going to get a metal oxide. We are going to get a nitrogen dioxide gas and oxygen gas as well. Let me read. Yes. If it's for 1 mark, you are going to get 0 mark. If you made the equation correctly, but you didn't able to balance it correctly. But if the equation is for 2 marks and you made the equation correctly, but you missed or you did the balance wrongly, then you will get 1 mark. To a small sample of copper nitrate, a student adds the aqueous ammonia drop by drop until it is in excess. See, that is the test for a cation that the table is going to provide you in your paper 4. But for paper 2, you have to remember those steps. So whenever there is a copper ion, see, it's an aqueous solution. And we are adding the ammonia drop by drop. So on adding ammonia, okay. So the light blue precipitates are formed, and when we, add the ammonia in excess, what would happen? That these light blue precipitate dissolves and a dark blue solution will form. Okay, so no, you have to write the colors. No, I am just telling you, for example, if the examiner asks me the observation in the next part, not usually examiners do this thing, but not for this equation. Okay, so what is observed? So first, blue precipitates initially when, yes, aqueous ammonia is added in excess, precipitates dissolves and deep blue solution is formed. Okay, it is wrong this form because solution is already there. So instead we write that and solution turns deep blue. Yes, the color of the solution becomes deep blue or the solution turns deep blue.
Sir,
Is this
deep
clear
blue
to
doesn't
everyone?
matter if it's copper sulfate.
No, copper sulfate is a blue, not deep blue.
Oh, okay.
The student repeats the experiment but adds aqueous sodium hydroxide instead of aqueous ammonia. Yes, but first you have to write like precipitates form, which does not dissolve when excess sodium hydroxide is added. So, in the initial observation would be saying that blue precipitates form which are insoluble in excess sodium hydroxide, excess aqueous sodium hydroxide. Now, question number 9. Iodine reacts with a chlorine to form iodine 1 chloride. So, see, they have written the iodine 1 chloride, which is clearly indicating that iodine is going to be a +1 and chlorine is going to be a -1 because the oxidation number, which is always written in the Roman, must be for a positive ion. Okay, it is not for a negative one. So, iodine chloride reacts in a similar way to bromine. Okay, iodine chloride reacts with the ethene in addition reaction. Draw the displayed formula of the product of this reaction. So, what would happen if you recall, if you compare it with the reaction of a bromine with ethene? In ethene, let's assume the empty bonds are hydrogens. So, when bromine reacts, a double bond turns into a single bond. right? And both the carbons have a 1,1 bromine. Now, instead of bromine, what we are doing, we are reacting the ethene molecule with iodine 1 chloride. So what would happen? One carbon have a iodine with it and the other carbon have a chlorine with it. The iodine chloride is going to broken down and the double bond of ethene is going to break down, and one carbon gets the iodine from the iodine 1 chloride and the other carbon gets the chlorine. Okay, is this clear?
Yes, sir.
Iodine 1 chloride reacts with us in a similar way to chlorine. Iodine 1 chloride reacts with ethane in the photochemical reaction in the presence of ultraviolet light. State the type of a reaction that takes place. Yes, can anybody recall the reaction of an alkene with a halogens? It's a substitution reaction. Very good. It's a substitution reaction. Now, part B2, suggest a simple equation for the reaction between iodine 1 chloride and ethane. Okay, so simple equation, ethane is C2H6, iodine 1 chloride is ICl, forming C2H5. Now it doesn't matter where you put the chlorine and where you put the iodine. So I can put a chlorine over here and iodine with the hydrogen forming Hi, or I would do the vice versa, writing a CH5I and HCl. Both are considered as correct over here because they haven't mentioned anything that which halogen, either iodine or chlorine, is going to bond with the carbon or the hydrogen. The dot and cross diagram for a molecule of iodine 1 chloride is similar to that of a molecule of chlorine. Okay. Draw a dot and cross diagram of a molecule of iodine 1 chloride. So if it's a similar to a chlorine, so what you will do, you will make a one circle having a arcs in a center I and the other circle having a chlorine in the center, right? Both have a 7 electrons, so both needs one. So what would happen? One shares the 1 electron and the other atom shares the 1 electron as well. So now there are 6 more electrons which are left for each atom, which I will make on the circle showing their remaining 6 electrons. Is it clear?
Yes, sir.
Okay. Now D part. Iodine 1 chloride reacts with chlorine to form iodine 3 chloride. So it is clearly telling me that iodine is +1 over here, and here it turned into +3. So it's a redox reaction, and in that redox reaction, iodine +1 is the one which undergoes oxidation. And if it undergoes oxidation, so it means it's someone which is behaving as a reducing agent. Okay. And it's a reversible reaction as well. Describe 2 features of a reversible reaction at equilibrium in a closed system. So the 2 features, the one would be the rate of forward and the backward reaction are same or is equal. This is the one feature. The rate of forward and backward reaction is equal. And the other feature, can anybody tell me? The amount of reactants and products are constant. The amount or the concentration, you can use the word concentration as well. The amount of
It's constant.
Sorry?
Concentration is constant.
Yeah, the amount or the concentration of reactants and products are constant. Stays constant, it doesn't change. Now, the pressure of the equilibrium mixture is increased. The temperature is kept at 200 degrees Celsius. What they are saying that we are increasing the pressure. ICl is a dark brown and ICl3 is a yellow. So what would happening? ICl is reacting with a chlorine, forming ICl3, and they have told us that it's a dark brown, right? and it's a yellow. So if the equilibrium shifts towards the right, there would be more of ICCl3 molecules, so the color of the whole container becomes yellow. And if the equilibrium shifts towards left, then there would be more ICL molecules in the mixture, so the container's color becomes dark brown. What they are saying, predict and explain what will happen to the color of the equilibrium mixture. Okay, so what would be the prediction? Yes. So where the equilibrium would shift? Where the equilibrium? Yes, very good. Where the less moles of gases are there. So all are gases. So if you see, the product side have a less number of moles of gases. So equilibrium will shift towards the right. And if equilibrium is shifting towards the right, then when the equilibrium reestablishes, there are more moles of ICl3. So if there are more of ICl3, then what will be the color of the container? The color turns, or the color will be yellow. What is the explanation? Less moles of gases on product side hence equilibrium shifts to the left. Oh, sorry, shift to the right. Right, my bad, sorry. Equilibrium shifts to the right. Is this clear? Yes, the online students, is it clear?
Yes, sir.
Yes, sir.
Okay. Now, question number 10. Air contains a mixture of gases including noble gases, neon, argon, krypton, and xenon. These noble gases are monoatomic elements. What is meant by the monoatomic?
Composed one atom. Molecule composed of
Exists
atom.
as a single atom. Exist as a single atom. Why noble gases are unreactive?
सर ये बोल सकते हैं कि मॉलिक्यूल की फॉर्म में एग्जिस्ट नहीं करता.
Can you repeat, Hassan?
ये बोल सकते हैं कि मॉलिक्यूल के फॉर्म में नहीं वो एग्जिस्ट करता.
No, we can't say that because it is considered as a single atomic molecule. They normally called as a monoatomic molecule as well, which means a
So we can
molecule
say full outer shell.
Yeah, for a noble gas as the unreactive, we can write that
Valence shell is complete.
or the valence shell have a complete octet.
Yes, completely fit.
Valence shell have complete octet. State why fractional distillation can be used to separate. Okay, why fractional distillation can be used to separate liquid mixture of neon, argon, krypton, and xenon. So if we are using fractional distillation, it clearly indicates that these gases have a different boiling point. That's why these gases have different boiling points. What mean? State which gave noble gas neon, argon, krypton, xenon as the fastest rate of diffusion. Yes, if you look in the periodic table, you will find neon among these in the top, and then beneath neon there is a argon, and then there is a krypton and xenon. So neon is the one which have a lowest MR, so it would be the fastest. So the answer would be neon, and what we would write that its MR is smallest among all the noble gases that have mentioned. So what is MR or AR? Basically, these are the monoatomic, so I may write AR. Air also contains oxides of nitrogen that are pollutants. State one adverse effect of oxides of nitrogen in the air. Yes.
Damage to the human respiratory.
Acid rain.
Acid rain.
Sir, so nitrogen oxide or sulfur dioxide, दोनों acid rain cause
Yeah, both can take part in the acid rain. Okay. With the aid of a symbol or a word equation, explain how oxides of nitrogen such as NO is formed within the car engine. So it's very easy. So there is a nitrogen in the air because car engine takes the air inside to combust the petrol. So due to high temperature, that nitrogen reacts with the oxygen to form nitrogen oxide. And why this reaction is occurring? Because of high temperature. Is this clear to everyone?
सर हम catalytic converter नहीं लिखेंगे.
They didn't ask.
Oh.
Catalytic converter turns the nitrogen oxide into nitrogen, right? They are asking how nitrogen oxide is forming in the engine. And the catalytic converter is at the exhaust. When these gases are formed in the engine by escaping from the exhaust, at exhaust there is a catalytic converter fitted which turns these gases into less harmful by turning nitrogen monoxide into a nitrogen which is clearly harmless, but carbon monoxide into carbon dioxide. That happens at the exhaust, not in the car engine. Okay.
Yes, sir.
Okay, sir.
Now, okay, question number 11 as well. That is the last question. Yeah. No, there is no choice now. Yes, so you have all the questions to attempt. Might be they give you 10, might be they give you 12, might be they give you 9, but there would be no choice in no section B. As it was clear that you have a section B where you have a 4 questions each of 10 mark and you have to do 3. So now there is no that such option in the new pattern. Okay. Shows some information about the homologous series of unbranched carboxylic acids. One of the characteristics of homologous series is that it has a general formula. Reduce the general formula of the homologous series of unbranched carboxylic acid. I hope you all must remember that because we have discussed it so many times in the class. CnH2n plus 1 COOH, or the other general formula can be CnH2n O2 as well. Describe 2 other characteristics of the homologous series.
Same functional group and similar chemical properties.
Very good. Same functional group and similar chemical properties. Just give me a minute, please. Okay, now B part. An aqueous solution of propanoic acid is a weak acid. Define the term acid.
Proton donor.
Which releases the hydrogen ion or which donates the proton. A hydrogen ion donor is an acid.
So we can write it's just a proton donor. Right?
Yeah, you can write a proton donor as well. Okay. Butanoic acid reacts with ethanol to make an ester. State the name of ester made and draw the displayed formula of the ester linkage. Okay. So ethanol turns into ethyl while naming the ester, and butanoic acid turns into butanoate. So the name would be ethyl butanoate. Okay. Now displayed formula. So ethyl, 1 and 2 carbon. First carbon have a 3 hydrogens. The second carbon have a 2 hydrogens. So that becomes ethyl. Then for butanoate, a O, then a C double bond O, then C, C, and C. Now that is a butanoate. Now put the hydrogens on each carbon. Okay. Is this clear to everyone?
Yes, sir.
Now, ethanoic acid is liquid at room temperature. Describe the changes in the arrangement and the movement of molecules of ethanoic acid when it is heated from room temperature to 120. You have to discuss what? The changes in the arrangement and movement of the molecules. And it's of 3 marks. So, as temperature increases, molecules move faster. Further, they further apart, right? And are more irregularly arranged. Is the liquid, so initially they are irregular, but because the liquid goes to a higher temperature, then it would be more irregular, right? So here we have finished the whole specimen paper. Okay, so now I'm ending the class over here. Now in the next session we will be practicing some paper 4 alternative to practice calculation papers. Just like to everyone, just remember, stay calm in the exam, okay? And just do attempt the initially attempt the questions which are easy for you and which you can do it easily. First, do those one, then come to the one. Try to attempt the rest of the one where you have to think. Okay, the one which you find difficult, do it later on. The first, do it which are easier for you. Okay, so take care everyone. Allah Hafiz.
Allah Hafiz, sir.